The twin spacecraft Voyager 1 and Voyager 2 have operated in space for 45 years, far surpassing their original 5-year mission plan. Despite the passage of time, the spacecraft continue to send strange signals back to Earth. Scientists believe that we will maintain contact with the Voyagers until 2025, but the question remains, will they have time to show us anything else? Is there a chance their journey could continue? The Voyager missions were initially launched to explore Jupiter, Saturn, and their major moons, with the goal of photographing them. Thanks to these images, scientists were able to observe the surfaces of Saturn's moons, which had previously only appeared as bright dots. This marked the beginning of a series of discoveries, particularly concerning one of Saturn's moons, Enceladus. Researchers were astounded to find that some of Saturn's moons exhibited geological activity. Moons are usually pockmarked with craters, scars left by collisions, and these craters typically remain because most moons lack geological activity. However, Enceladus appeared smooth, almost like pearls, which suggested it might be forming an atmosphere and perhaps even have the potential for life in the future. Today, scientists know that Enceladus' smooth surface is due to cryovolcanism, a phenomenon where melted ice displaces ice masses and forms new ones. However, in the 1970s, this discovery was still far from understanding. The Voyagers also revealed surprising features about Jupiter's moon Io. From a distance of 800 million kilometers from the Sun, Io had previously been thought to be a small, icy rock. But the Voyagers presented a very different picture: raging volcanoes. Ash plumes from Io's largest volcano reached heights of 400 kilometers, marking the first time scientists observed active volcanoes elsewhere in the solar system. It turns out that Jupiter's immense gravity causes Io's tectonic structures to constantly shift, leading to extreme volcanic activity and magma emissions far beyond the Moon's surface. In addition to these groundbreaking discoveries, the Voyagers also uncovered Jupiter's radiation belts and the planet's previously unseen planetary rings. Voyager 1 first spotted these rings in 1979, and Voyager 2 followed with more detailed imaging. This would set the stage for future missions, including NASA's Cassini spacecraft, which studied Saturn for 13 years. Without the Voyager's earlier observations of Saturn's rings, scientists might not have been motivated to send Cassini. The same goes for Saturn's moon Titan. The Voyagers were the first to detect liquid seas on Titan, a discovery that was later confirmed by Cassini, some 40 years after the Voyagers made their initial observations. Although the Voyager missions were originally expected to last only 5 years, their mission was unexpectedly extended. Voyager 2 went on to explore Uranus and Neptune, while Voyager 1 continued on its trajectory toward the distant moons of Jupiter. But how did they manage to extend their mission when they were designed to last only 5 years? The twin Voyager probes each weighed 773 kilograms, and they carried 105 kilograms of scientific instruments, including the Imaging Science Subsystem, ISS, which featured 2 television cameras, a wide-angle camera with a low resolution and a narrow-angle camera with higher resolution. These technologies seem almost rudimentary compared to modern instruments like the James Webb Space Telescope. Yet, despite their limited capabilities, the Voyagers managed to make a significant impact, transmitting hundreds of thousands of photos despite having only 67 megabytes of storage. Today, that's less than the memory of a modern smartphone, highlighting how far the technology has come since the 1970s. However, it wasn't just about the cameras. What made the Voyagers so remarkable was their power source. Each spacecraft is equipped with 3 radioisotope thermoelectric generators, which use the decay of plutonium-238 oxide to generate power. As the plutonium decays, the spacecraft's power diminishes. By 2011, the power had dropped by 57% from its launch levels, and the remaining energy was insufficient to keep all the subsystems running. To conserve energy, engineers decided to shut down some of the spacecraft's instruments. This brings us to another critical aspect of the Voyager missions: their trajectory. Scientists carefully selected the launch time to take advantage of a rare alignment of the outer planets in the late 1970s. This alignment, which occurs about every 175 years, allowed the spacecraft to follow a particular trajectory, making a 4-planet tour with minimal propellant use and shorter travel time. This technique, known as gravity assist, allowed the Voyagers to gain speed from the gravity of each planet they passed, cutting the flight time to Neptune from 30 years to just 12 years. By the 1990s, Voyager 1 had overtaken Pioneer 10 and Pioneer 11, becoming the most distant human-made object in space. But with the increasing distance between the spacecraft and Earth, maintaining communication became more difficult. As the Voyagers traveled farther from the Sun, their ability to transmit data diminished. For example, when Voyager 2 moved from Jupiter to Saturn, the data transfer rate was halved. Today, Voyager 1 is 18.5 billion kilometers from Earth, and Voyager 2 has traveled 15 billion kilometers. Despite their vast distance, they continue to move at speeds of over 60,000 kilometers per hour, and communication is still maintained. The spacecraft are now searching for the boundary between the heliosphere, the region influenced by our Sun, and the interstellar medium. Voyager 1 has even recorded sounds from space, where no sound should exist, caused by the collision of solar wind waves with waves from other stars. The Voyagers continue to transmit valuable data, but challenges persist. In 2022, NASA announced that Voyager 1's attitude control system appeared to be malfunctioning, causing the spacecraft to send back random numbers. The engineers are still trying to understand the issue, but with signals taking 20.5 hours to reach Earth, troubleshooting has become an arduous process. Another challenge is the diminishing team of engineers, once numbering in the thousands. Today fewer than 20 people work on the Voyager missions part-time. Despite these challenges, the Voyagers are still sending valuable information and continuing their journey through space. Eventually, the Voyagers will run out of power. However, they won't be stranded in zero gravity. They will continue to drift through space, but their antennas will no longer point toward Earth, and they will cease sending signals. Having passed beyond the influence of the solar wind, they will eventually cross the Oort cloud, a distant region of icy debris and comets. This will mark their final destination within the solar system. Though contact will be lost, the Voyagers will remain silent witnesses to the phenomena of space. In approximately 500 million years, the Voyagers and the entire solar system will complete a full orbit around the center of the Milky Way. By then, Earth could be unrecognizable, as continents form and collapse over eons. As the spacecraft continue their journey, they will oscillate up and down through the galaxy, with Voyager 1 traveling so far above the plane of the galaxy that it will witness stars at half the density of what we see from Earth. This vertical motion also affects the spacecraft's chances of survival, as the Milky Way's vast clouds of interstellar dust pose a significant risk. Dust grains, even those as small as 1/1000th of a millimeter, will leave craters on the spacecraft, slowly eroding their hulls. While this won't change their trajectory, it could alter their orbits. Despite these hazards, the Voyagers may still encounter other stars. Voyager 1 is heading toward the constellation Ophiuchus and will eventually pass near a red dwarf star named GLE 445. Meanwhile, Voyager 2 is on a path to the constellation Sagittarius, where it will pass a star called Ross 248. The Voyagers could even pass stars that have yet to be born. But why should we care about their journey, especially if humanity no longer exists by the time they reach these distant stars? We should care because the Voyagers carry precious cargo, 2 golden records containing information about humanity and Earth. These records include photos, sounds of animals, birds, and greetings in multiple languages, including hello from children. They also contain a map of our solar system relative to pulsar stars, as well as instructions on how to play the records. Designed to last billions of years, the records are housed in protective aluminum covers beneath their gold plating. If the records survive, they could remain intact for up to 5 billion years, until the Andromeda Milky Way collision. Afterward, the Voyagers will continue to drift through unexplored space, carrying the legacy of humanity's achievements. Even if intelligent life never discovers them, the Voyagers will stand as a testament to our once existence, a symbol of our journey across the universe.